Good day, everybody. This, again, is the special interesting report for the Method and Tools Committee. This is headed by Bill Barrett, again, of the US EPA. Jasper and Mark also work with this committee. Mark has been especially helpful with the threading model, with the COM interoperability between the new threading model that we'll have to have with COBIA. So his opinions there have been very helpful for us to shape that area. Anyone is welcome to join us. If you are wanting to join us, there's the contact information for Bill at the bottom. Also, Michelle can get you into that information. This report, while I'm here physically giving it, is really very much a collaborative effort. Bill put most of it together. I'm just actually delivering most of his work to this group here. If you do want to join us, here are the times that we meet. We typically have 4 conference calls a month. Tuesdays are the days. Those are the times that are listed there. And we also have typically once a month a inter-SIG group conference, joint conference meeting with them on the 3rd Wednesday, once a month there at the times again listed on the screen there. The charter has not been changed. Essentially what it is there, improve integration and expand utilization of computer-aided process engineering applications within the enterprise through identification and resolution of existing cost-cutting issues within the CAPE open platform, develop mechanisms for use of CAPE within other application domains, and incorporate advances in information technology into the CAPE open platform. And there are our responsibilities at the bottom. We've done a lot of work with the common interfaces. We also do a lot of work with COBIA, with that new design that comes with COBIA. Here's some of our activities that we've done over the last year. Let's see, COBIA maintenance and development and testing. We did a lot of work with that with phase 3 with work package 1. As of this time, we've developed a generic TCP/IP marshaller, and that's been completed. And we're developing marshallers for more optimal use at this particular point, as well as on-the-fly proxy generation. We've also started that work. We've also done a lot of work in the area of threading. As again, I mentioned, Mark had a lot of input on that. I'm not going to talk too much about threading because Jasper is going to concentrate on that in the next presentation and what we've done with regard to threading. We've also done working with the interop SIG in the area of certification and versioning. And we also have developed the test specifications for the common interface specifications, and you see those listed below there. A little bit about the roadmap to COBIA. You'll see a lot of it has been completed, but there's also a lot still to be done. The proof of concept there was not completed, and that was essentially a interface to Thermal 1.1, and we proved that several years back. We have, for the most part, completed phase 2 as well. That was the Windows development, C++ development. There's ongoing maintenance associated with that, but other than that, the development aspects are essentially completed. And we are now in the process of doing phase 3, which is really marshalling work and threading. That we'll talk a little bit more about that here in a moment. And documentation will need to become in the future. That really has not started. The timeline, the first prototype was issued in October of 2016. That was using version 1.2.0. Phase 3 release of marshalling package will occur after we complete the threading architecture. Documentation is under development as well for that. That documentation will require an RFC for approval down the road. But here's essentially the timeline that is taking us to today with what have we done as far as phase 2 maintenance. There have been 9 maintenance releases to date. Most of them are to resolve issues in initial development related to commercial applications. Currently, COBE is actively used in commercial applications with more than 12 months of commercial use. Feedback has been positive, indicating that it's been easier to use in COM. Little maintenance has been required. We have had no end user issues reported at this point. The product has reached some maturity in that regard, in that we've only had one maintenance release of COBE since the last annual meeting, and that was version 1.2.0.9. It was released in March of this year. It also included a symbol server update, and according to Michelle, the SDK has been downloaded 93 times. We divided the work into for the phase 3 into 4 work packages. Work package 1 is marshalling. Work package 2 is language bindings, various computer languages we're talking about. Remote computing is work package 3, and logging is work package 4. Currently, work package 1 and 3 are under active development or discussion. The others will be underway in the future. In work package 1, again, that's the marshalling work package, an update on what's going on with that. The COBE marshaller is required to marshal data between threads, processes, and network connected systems. The general marshal that we developed is based on TCP/IP transport. It can be used for any marshaling scenario. Marshaling between network connections, though, will require future enhancements such as encryption in work package 3, which is, this is work package 1 again. Marshaling code is currently in the source code repository, and if anyone needs that marshaling package, we can actually get that to you through some mechanism. You just need to contact us, and we'll work with you to get that. Since TCP/IP is not the most efficient method for all scenarios, we're looking at other more optimal methods to perform this marshaling. A shared memory transport mechanism is being developed to provide better performance on a single system. It's designed for out-of-process marshaling between 2 processes, but it does require synchronization, access to shared memory, and that's going to take some effort to develop. And we also are developing a C++ heap-based method, which is very similar to the shared memory approach, but again, this is for a single process instead of marshaling between 2 processes. This will allow optimization of in-process applications between 2 separate threads. We've also worked with on-the-fly proxy generation. We tested that with the live FFI package. This allows automatic creation of proxy classes instead of us having to actually manually hand code this code. And again, that has been tested. We've also, this will also allow us to do more custom interfaces in the future, and also help us with some of the COM interop and some of the other language bindings as well. Coping threading architecture. We're going to need to complete this, obviously, to complete the marshaling. There are several considerations that we have to take under care here with regard to threading in our design. First of all, we want a modern, flexible approach to multi-threaded applications. We also have to establish who is responsible for synchronization between the data to make sure that the right party synchronizes the data in the correct manner. We also want to design it so that we minimize the need to marshal calls. Marshaling calls add a lot of time and overhead, and because of that, we need to make sure that we minimize those marshal calls. We also need to consider interoperability with COM so that we don't break existing applications that are out there. We proposed 2 different threading options at this point. Default threading allows the PMC to be called directly from any thread by the PME, but only a single thread at a time. And while restricted threading requires that all calls originate on the same thread that it created the object, and this is similar to COM apartment threading. Again, Jasper will give more information on this in the next presentation, so that's all I can say about that at this point. COBIA Phase 3 language bindings, this is work package 2. In the 2020 meeting, the COBIA members were surveyed about language bindings, and according to Michelle, these are the candidates that received votes here at the bottom: C, Python, Fortran, and Microsoft.NET. C had some benefits, even if it didn't get the highest number of votes, because it may be a vehicle to aid us in developing Fortran interfaces as well as other possible languages down the road. So C probably has a relatively high priority because of its general use that's available to us. Now, any language that we actually do deploy is contingent on the software vendor stating a desire to the management board that we need that language. Without the management board directing us and providing that approval, we're not going to be developing any language binding for that language. So you need to provide feedback to the management board if you have some requirements in this area. Phase 3 remote computing and logging work packages. Work package 3 will allow COBIA interoperability between two computers connected on a network. This will include internet-based communication and encryption of the transport layer. Features required for this implementation will be guided by member needs. Work package 4 is a logging package, allowing logging calls over the COBIA pipeline or transport layer. And it enables us to develop logging applications that can trace calls between client and server applications for debugging purposes. These work packages can be initiated once work package 1 is completed and the marshalling work is all done. We've also worked with, again, this interop SIG in the area of the testing specifications that are relevant to our group. Here's a little bit of information about them. The MMT SIG, again, is we are in charge of these 4 interfaces that I showed you on an earlier slide. And so we've been working with the testing on those 4 particular interfaces because those are under our charter and we're responsible for developing that. We're also hoping that once we get that done, that those interfaces will be a model for other SIGs to use to aid in developing test specifications for the interfaces that they're in charge of. Let's talk about the test cases a little bit. The test case document is formatted similar to that of use case documentation. The content of a test case is based on interface requirement, use cases, and method descriptions. And where applicable, the test case checks for correct return values. The test cases includes ensuring that the PMCs also support the required interfaces. This is an example of the test cases that are available or the precedent for ICAPE identification. I'm not going to really go into this too heavily, just to kind of give you a flavor of what's going on here. We want to make sure that the interface exists on the object, so that's, for example, what the first test there is for. Then other tests are related to checking the component name, make sure it obeys the rules with regard to white space, make sure it obeys the rules with respect to control characters, and the same thing with description, make sure it obeys the appropriate rules as well. So you see that at this point we've identified 10 tests that we are using for ICAPE identification, and those are listed there at this point. Those are still somewhat under development as well at this point. The collection, we've also started on that one as well. It's a little simpler to do. Essentially, most of it is, again, related to does the interface exist when it needs to exist? Can it properly retrieve a count of items in it? Can it properly obtain the value by index as well as by name. Are the names unique? Is the counter one index? Those are the different tests, again, that are here as an example. This slide here is somewhat complicated and don't expect you to read it all, but we're just trying to give you a flavor of what the documentation here looks like for this particular test. It's ICAPE identification, use of white space and default component name. The key thing here is step number 4. It shows you the test, the guts of the test, essentially, what we're actually looking for. And again, it's just simply making sure that the component name actually does follow the rules that are stated in the specification with regard to spaces and with white space. For example, if I remember right, you can't start with a white space is one of the big items that are there. And I think you cannot end with a white space as well. Those are 2 of the ones that I remember off the top of my head that are required. Activities for the future, or the upcoming year. We're going to continue to work on COBIA phase 2. That's again the maintenance. If any more maintenance is required, we'll deploy those packages and release those. We're going to complete the documentation of the COBIA threading that architecture that again will require an RFC. COBIA phase 3 work package should be released as version 1.2.1 with marshalling and multi-threading support. We're going to continue to work and develop test cases for the common interfaces. We'll be working to update the existing interfaces and issue new specification documents. The update to the persistence and the parameters interface will require version 1.2 of CAPE-OPEN. We will be updating errata and clarifications to the identification interfaces. That will be in version 1.1. And we're going to finalize the reporting and managers documentation and development. And we'll also continue to work with the interop SIG as needed. That's it.